All right, hello there. Welcome to the Off by One security stream on March 15th, the Ides of March. So today we've got very special guest, Duncan Ogilvie. I've been looking forward to this one. As you probably very well know, he is the developer behind x64dbg and works currently in mobile space. We'll just call it that. Mobile security space.
Yes.
But yeah, so a lot of you guys have been asking for to have some developers of debuggers and such on, and I remember in computer science in university, you had to write like your own debugger, but it was like a sad little thing. It was like basically like a disassembler. It wasn't really a debugger, but it was like a dead listing thing. But it was quite the effort. So I guess first thing I'll just throw at you, Duncan, is what does it take? Like, how do you begin to write a debugger?
Well, believe it or not, but actually the same way that you did it in university, I guess. I started out as just a little tool, like to, I don't know, with a few Windows APIs, like to start the debug loop, and then have a command to print the disassembly and the stack and stuff, and basically, yeah, it grew from there. So yeah, that's exactly how it started.
And it just grows and grows and grows.
That architecture you can still see in the code today. So it's like that's how basically.
Yeah, it's awesome. So it's written in C++, I assume, or what language?
Yeah, C++. I mean, kind of like it started out before I really knew C++, so it was then kind of like C with a bit of C++, and now I'm kind of try to, use a little bit more modern stuff, but it's C++, I guess. Yeah.
Nice. Yeah, I saw some people in Discord already asking you, why not Rust?
Well, Rust didn't exist 10 years ago when I started, so that's one reason. The other reason is I wouldn't I mean, I saw someone ask like, yeah, what would you do differently? Would you rewrite it in Rust? But I definitely wouldn't, because the UI frameworks in Rust are just not there yet,
Yeah.
to be honest. So yeah, that's I like recently someone asked me this similar question, and actually, yeah, I would probably rewrite it with some web technologies, honestly. That's yeah, I think that's the future for this stuff, for the UI at least.
Yeah, for sure. So folks online, I know a lot of you have questions and such, and I know there was some posted on Discord. If you wanna, do you have Discord up right now, Duncan, or do you want to go and fetch those?
I have it, yes, on my other screen.
Awesome. Yeah, because I know a lot of you sent some good questions in between the trolling that was going on in the channel. There was plenty of good questions.
Yeah, Jonas was salty. He got those cat ears, I think. The questions. Well, let's see. I wrote them somewhere here. So yeah, people asked some questions. I think the first one was from Brimco, which was that are you worried that one day x64dbg will be replaced with another tool? And my answer would be a strong no. I would be super happy because then someone else will be maintaining that, right? But basically, no. I'm happy. Like there's more tooling. Like 10 years ago, there wasn't much. There was just WinDbg, and it wasn't very nice back then. At least the UI wasn't very nice. The tool is always very stable, but kind of difficult to use. So yeah, no, I'm happy for all the new tools that are coming out. Like Ghidra came out. They have a debugger, so I hope that will improve, and Binary Ninja also. So yeah, I'm happy. Only happy. More tools is better, right? And you learn from each other, and basically it improves the whole space. So no, definitely not worried.
Yeah, for sure. Oh, they're on here right now. I missed your voice, says Brimco. Nice. So yeah, what else did you have up there on your side, so I can not ask you the same questions?
Well, so someone Nob asked something about how do you think the AI revolution will affect the RE industry when it comes to vulnerability research, malware research, anti-cheat, and also from a career perspective, which I don't know, it's not my field of expertise, this AI stuff, but from what I've seen personally, it's really nice. Like Copilot is great, and I use it a lot, but I don't think it will affect at least something like x64dbg. I don't think it will be affected much, because those AI tools are nice, but you cannot really trust them. So, yeah, sure, you can give it some disassembly snippet and ask where's the overflow, and okay, maybe maybe it's a nice thing to start with, but at some point, in my experience, it always falls apart. So
Yeah. Like I remember back when DARPA in the United States had like these contests going on where they're trying to have like capture the flag games being played by basically AI.
Yeah, those autonomous systems. Yeah.
Right, and for something like a simple stir copy buffer overflow on the stack, yeah, it can obviously weaponize that quite simply. But if you're talking about something complex like a type confusion bug in some complex C++ application, it's very difficult to kind of find those things by static analysis just by looking at the code. So I think there's still always going to be space for solid researchers out there for sure.
Yeah, I think that Tim Misiak, the previous developer from WinDbg, he put it very nicely, which is that like the ability to debug will be the new COBOL in 20 years, which I think, yeah, could be accurate. Because yeah, like, when you actually go through the code step by step and you kind of get a feeling for that, like how you debug something, I think that's a valuable skill. So I don't think that if you have such skills that your career will be affected in any way. I think for new people, it's sure it will be affected for sure. But if you already have experience, I think it's, they always need someone when the AI doesn't have to find the answer, right? So.
Right, and everybody obviously needs to use it as an aid. Don't fight against it. Use it as an aid to make you better. But absolutely, I mean, I think a lot of people are going to just rely too much on AI writing their code, and it's going to dumb people down. I mean, if AI is writing all the code, how do you know what's going on? So, so
Yeah.
somebody there's asking about. Actually, I'll let you answer this one too, but I'll just give my take first. Somebody's asking about phone exploitation, like iOS and Android. I mean, I've said this many times before that the knowledge level that you need to have to get into iOS exploitation in today is extremely advanced, and that stuff is held close to the chest because you're looking at 7-figure bug bounties on that one that you can make. I would say Android's still going to be a little bit more friendly to get into, but at the same time, most of those people are looking at older versions of Android. They've got a lot of new protections coming out, especially on like the ARM processors and such, and the hardware protections are just growing and growing, and it's a real tough one to get into. So I mean, with regard to iOS exploitation, I really think that's something that it's going to be quite a challenge. You're going to need to find a team of people where you can help them and they can help you. What are your thoughts, Duncan?
On mobile exploitation, or
Yeah,
what do you mean exactly?
mobile exploitation.
Yeah, I mean, I do agree with you for sure that it's really hard, and like a lot of the stuff we see now, it's like especially with those hardware mitigations like ARM Trust Zone, I believe, or Secure Boot, whatever it's called. With those things, like the platform basically, you can close it off, I think. So yeah, even getting your own code to run there, it's tough. And the exploits, I think I don't know that much, but like the exploits that I saw on Android are all like related to like GPU or some kernel exploits that are really tricky. So yeah,
Yeah.
I don't think AI is gonna help you there much for sure.
And oftentimes like 6 or 7 exploits chained together. I mean, when Apple came out with what's it called, Blast Door, I think it is, because all the iMessage, that was pretty much the main gateway people were trying to get in for the 0-click remote code execution exploits, and like Blast Door is a way to contain that. So if you do get code execution, you're like in an isolated environment. So I haven't looked too much into it, but I've read some papers there. It's quite neat the way they've done things.
Yeah.
Yeah, so back to debugger, like one of the things that people ask a lot is around structures. And somebody might say something simple, like I remember a student in a class one time asked me, how does Immunity Debugger at the time, which hasn't been updated, I think it's version 1.85 for like 10, 20 years now, but but somebody said, like, how does the debugger know where the SEH chain starts on a specific thread stack? And I would say, well, there's something called the thread information block, which FS offset 0, if you dereference that, that's a pointer to the NSEH position. And that's all the debugger's doing to know how it's there. But I've noticed some debuggers are really good about types and enums and structures and all that. And the other ones, you kind of got to go and decode things yourself. What are your thoughts on that?
Well, yeah, I mean, my thoughts x64dbg doesn't decode structures that well, because what it was created for was like a situation where you do not have anything. So, WinDbg was created to debug Windows. So like they kind of can rely on the fact that you have PDBs or source code, and it's really good for that. But yeah, I noticed that when you don't have those things, it's much harder to use. And x64dbg is like more aimed at like trying to show you the best it can do without any of those things. But for example, SEH is supported, so yeah, that's like a standard thing, I guess. I mean, honestly, it's been years since I looked at it, but yeah, it just looks on the FS0, and then there's the stack chain, right? So it has a little comment that says that the SEH handler and then the index, basically, it's here. So yeah, it shows that.
Somebody DM'd me a question. They said, "What about time travel debugging? Are you planning on implementing that, and how does it work?"
How does it work? Well, if I plan to implement it, basically no. Like, to be honest, it's been 10 years since I started this project, and like I don't have that much time. Like, I got a job when I was 17 when I started. Yeah, I had all the time in the world, but now I don't, right? So I don't have time to re-implement such a big feature because it's huge. There is something kind of similar, like on a very small scale, you can trace the execution and you can see go back in time with the registers. But yeah, like time travel debugging, basically, it emulates the whole process. That's how it works, and that's how it can basically replay the whole execution. And yeah, when a syscall happens, then it kind of takes a snapshot before and after and stores the diff, and that way it can like recover all the memory and stuff like that. At least that's my understanding how it works. I didn't actually disassemble it much, but I saw some talks about it, and yeah, I think that's how it works roughly.
Yeah,
But it's really great. That's also just wanted to say, like, it's a really really nice technology. If it works on your use case, I tried it on games. It doesn't work, unfortunately. It's like too much going on, I think.
Oh wow, you were 17 when you started the project. That's awesome. Yeah, like I know one of the main things people want to see is like let's say it's a simple stack buffer overflow because everybody can understand that one. And when the debugger catches it, like you see 41414 whatever in the registers, but there is no easy way for you to see like what were you returning from, what function were you returning from, because everything's messed up, so you can't really see exactly where the vulnerability was. Which in theory it should be very easy to see that.
Well, if you time travel, yeah, sure.
Yeah, that's what I mean.
Right? If you step backwards, yeah, you can see exactly what happened. Otherwise, I don't know, there is like, I guess those cyclic, what are they called? Non-cyclic patterns or non-repeating patterns or something.
Oh,
so I
yeah.
guess that would be what you would use, right? Like you would generate the pattern and then you would kind of see, okay, my return address is this thing, and then you can kind of find the offset. So at least then you can kind of know the size of your buffer that you need to set. And then you didn't overwrite all of the stack, and then you can just scroll down and see the return address of maybe the previous function or one above that. So I guess from there you could breakpoint, right, and then step into it basically.
Yeah, for sure. All right, so people love demos, so let's go ahead and I know you got some stuff to show. I'll go ahead and share your screen here. And while you're getting set up there, Randall, can you grab the link for the Discord channel? Randall's the marketing guy in the background, by the way, who's who I'm talking to, and post up the Discord link up here for everyone, because I want to say a quick shout out to Tyson and also Frostbites for being gold sponsors for the stream for this month, which is fantastic because those donations are coming in and they're being used for helping some people get education. So we're looking at different options, different classes, different companies we can work with to get like discounted education, and then use the funds coming in to pay for it so that we can give that to some people who may not otherwise have that opportunity. So thanks so much for people who have signed up for it as a member, and yeah, please consider that. So, all right, back to you, Duncan.
All right, so you can see my screen.
Absolutely.
Right? Yeah. So I have some slides also. I think somewhere.
Nice.
Yeah. So just for this first demo, I wanted to show how basically you can. Well, I want to explain a bit how the loading process works in Windows. So how the loader loads an executable and all the imports and stuff like that. And then I just want to show like how would you use x64dbg to, introspect that process and breakpoint there and see the structures maybe or the parameters, whatever. That's my goal for this. And hold up, I forgot. So this is just a super simple test application. It looks like this. And all it's doing is logging that, hey, I executed the entry point. And then it calls a little import from another DLL, just to have something in the IAT, basically. And then it creates a thread, and it waits for it to finish executing. And then finally, it just exits. So it's like a very simple program that just kind of has most of the features that kind of the loader has. And it also has a TLS callback. And then there is this import or this library, which is just very similar. It just has a function that it exports that, I don't know, opens some example.txt, whatever. And it has also a DLL main just to show that. And when you run it, you see something like this. Let me open the command prompt. So test app. So there. So this is the execution. So here you can basically see kind of on the console all the stuff that is going on. So yeah, like here we see the library that's being loaded, the TLS callback executed, and then eventually it calls our main thing, and it says that, oh, example.txt is 10 bytes long, whatever. And yeah, it creates a thread to show that, and then eventually it just exits the process. So that's the, I guess, the demo application.
Sure.
And in Windows, basically the process creation looks something like this. So like when you start the process, at first the kernel has control, and it will map basically k-user shared data, and it will map the executable file itself, so the test app in our example, and then it will map NTDLL and allocate the PEB, so the process environment block. And it will create an initial thread as well, which has a stack, obviously, it needs one, and a thread environment block. And then it will just set the instruction pointer on loader initialize thunk. And then from there, basically user mode gets control, and the loading process all happens inside of NTDLL in basically in userland. Except sometimes there's a syscall, right, and then it goes back to the kernel. So yeah, that's the rough flow. So the first thing we will do is just create a little breakpoint on loader initialize thunk. So actually, I will clear this database to empty it. So yeah, normally this is, if you would load an executable on x64dbg, this is what you would see. So yeah, it breaks at debugger break. And well, for the people who've never seen this before, so in the middle there's the disassembly, where the instruction pointer is basically highlighted in black or whatever color scheme you use. People always roast me for using the light theme, but I just like it more than the dark one.
It's good for presentations.
Yeah. Yeah, and then in the bottom here you have the memory view. It's called the dump, and this allows you can also switch between different like representations of the same data. So let's say I want to see 16-bit shorts, then you can also change that quite easily. Yeah, here in the bottom there's the stack, and then here on the top right there's the register view. And well, people sometimes ask like, why are some of the stuff green? And that's because that's basically the calling convention of x64. So the green registers are used for the arguments. The first 4 arguments are in the registers, and then after that it's basically on the stack. And there's also a little widget here in the bottom that kind of shows you that. And you can like, I don't know, show more arguments. Like kind of you can play with that.
That's a nice feature.
Yeah. And in general, x64dbg is basically, it assumes that there is no information about the binary, so no PDB, no symbols, and like basically nothing, no source, most definitely. And then it kind of tries to show you like not just, okay, the register RBX has this value, so you can see that there's a little calculator, so you can see, okay, there's RBX, which is 7FF, some whatever. Like it doesn't just show you that, but it also kind of tries to guess that, okay, that's actually an ASCII string that says loader initialize process, right? So if I right click on that, I can follow that in the dump, and then here, yeah, I can see the bytes actually, so you can kind of, yeah, you can the idea is that you can always interact with something, usually with the right click. So if you're lost and you don't know like what's going on, you can always try right click, because most likely there will be some option there at least for you to see something. Yeah, and the same in the stack. It like tries to show that this is actually the return address to this position, and well, yeah, it's basically trying to give you dynamic analysis information. Right. So the first thing we're going to do is go to. All right. So you press Ctrl G, but I guess people can figure this out. Loader initialize thunk, and then I will just set the breakpoint there. I press F2. And then I'll restart the process, because like right now we are already like way inside of the loading process, so we have to restart to get there. And yeah, now we are basically we have control of the process. So this is like the first instruction that gets executed in user mode. And now we can open this memory map here. So let me just detach it. So we have it here. And this is also a useful feature of x64dbg. But as you can see, it's like quite empty still, because there's just a few things allocated. So there are some hints here, like k-user share data, the PEB and TEB, and then there's NTDLL is loaded, and the application, and there's like a few more stuff that's also mapped, but it's not that important for this. But this is also always useful. Like if you don't know, what an address is, then you can always take a look in the memory map, and then maybe you see that, oh, it's a mapping to a file, or it's a, I don't know, section or whatever.
Right.
Right. Let's see. Yeah, so loader initialize thunk, it basically calls this, loader initialize function that does all the loading, and then it calls ZW continue. And this, we will also put a breakpoint on that, because that's kind of the transition when we will actually start executing the code in the process. So first there's the loader code, and then it basically unlocks this loader lock, and then it transitions to the entry point of the executable. So ZW continue is used for that. So also I will set a few more events here. So I have basically, I can set the system DLL events, like all the events I can enable. So then whenever the debugger gets this event, like, oh, DLL was loaded, it will basically pause execution so that we can kind of follow along what's going on. So yeah, so now we'll just run. And the first thing we see, so now it's paused, and then whenever it pauses, it should say in the bottom of the screen, it will tell you basically what happened, like why did it pause. And in this case, it says that, okay, we loaded kernel32.dll, which is always loaded. So yeah, that makes sense. So we can just continue. And now it loaded kernel base, okay. And now we see that the DLL main of the kernel base is executed. So, well, here you can see what is going on there. And actually, to load symbols, you can right click and you can do download symbols for this module. So I can do that again, but I already had them loaded. And also, if you want to see the loaded modules, there is the symbols tab that shows you basically all the loaded modules and where they are basically on the disk. Yeah, it's also a useful little feature. Right, so now I'll run again, and now we see that basically during the entry point of kernel base, it allocated this console. So this is also something, if you're interested at home, you can try to figure out like how that works. But there's some RPC going on and stuff like that. So yeah, now we have a console, which our application needs because we need to printf some stuff to this console. And then it starts executing the DLL main of kernel32. And now basically all the system stuff is loaded. So kernel base and kernel32, they're like system modules. And here we can see basically that now our test lib.dll gets loaded. And now when we run again, we see that, okay, the system breakpoint was executed. So basically this system breakpoint is something that just the loader checks if there is a debugger present. And if there is, it will just execute an in-tree instruction to signal to the debugger that stuff is kind of initialized, and now you can maybe inform the user about this about this breakpoint, and they can kind of decide maybe they want to set a breakpoint on the main of the program or whatever they might want to do. Yeah, and then we can run again, and then the TLS callback of our DLL gets executed. So now if we run, then we should see some output on the console. You see here, we got the TLS callback. And now similarly, there's the DLL main that gets executed. We can run again. And then we see another log file as expected. And now we are seeing that the application TLS callback is executed. So we can run again, and there will be more in the logs. And now finally, we see this ZW continue. And this function takes two arguments. And first of those is the context, that it will reassign the context to all the registers will be assigned to the whatever is in this context structure. And the second one is not relevant for now.
Is
but
that
now
context?
I can. What's that?
Oh, sorry.
Yeah.
I was going to say, is that context structure, is that stored in kernel land or is that stored in user land? Like something like the process control block, for example.
No, this one is stored in userland. So basically, this is a syscall where we ask the kernel to basically change the context to whatever we give it in the structure.
Yep.
And yeah, actually, I will show this this structure. So we can follow it in the dump. That address. So RCX is the first argument, if you remember. And yeah, here this is the context structure. But yeah, like this is not, you know, that useful, right? You just see a bunch of bytes. Okay, you could try to view it as address, then you can maybe figure something out. But yeah, obviously it would be nice to have some type information here. And yeah, a lot of people don't know this, but there is a feature in x64dbg for this. So in WinDbg, you would do DT to display the type.
Mm-hmm.
And in excuse me. In x64dbg, there's this little struct tab. And there you have to parse a header file. So this, I wrote my own parser for C here, so it's not that great, but you can see it looks something like this.
Oh, that's cool.
Basically, you just write the struct, you know, where's the context? Let's see here, struct context, and then you put you can copy roughly the C++ there. It just doesn't support everything yet. I'm still working on this, but yeah, I don't have a lot of time for this because it's kind of this chicken and egg problem, right? Like people don't know about this feature, so they don't use it, so they don't report problems, so I don't improve it, and it's like some kind of yeah, some deadlock there.
Right.
But,
And speaking on that, someone asked a question earlier, Amatsum, how are you planning on implementing any AI into the debugger? And whether or not you're planning on it, how could AI help a debugger? Like what could it do for a debugging session, do you think?
Well, yeah, again, my AI knowledge is not that great, so you know my imagination is somewhat limited here. But I don't know actually what this AI could do. I mean, obviously you can basically give it a screenshot of the screenshot, you know, a text file of the whole representation of what the user sees, and you could ask maybe, you know, given these logs and this position, what do you think could be going on here? I don't know. It might answer you. But yeah, for me, this is not that useful, honestly. I don't think it will be useful. And for the question if I will implement it, basically no. I don't have any interest in doing that. But yeah, maybe we'll get into that a bit later. But x64dbg is basically made for plugins. So it has a very extensive plugin system. And yeah, you could make an AI plugin conceivably. I mean, if you have any idea, like specifically what you want to ask this AI, then you know, feel free to reach out and I can help you find the right APIs and stuff to get that data. Because yeah, I don't think I'm going to implement it, but I'm happy to help anyone who wants to make a plugin. I mean, that's kind of one of the core design principles of x64dbg is that basically it's extensible. So yeah, you can quite easily integrate like your own UI widgets or your own commands and stuff like that. So yeah, I hope that answers the question. So where was the structures, right? Well, is there any other questions, or should I continue?
Well, I don't want to break your train of thought. I can ask him now, or we can wait to a pause when you're at a good spot. Up to you.
Yeah, let's wait a bit, and I will finish this,
Okay.
and then we can. Yeah. So yeah, you can go in this tab, and then you can parse a header. So yeah, I can share this header, by the way, after the stream. I can share all this stuff. But I made my own header, which contains basically PEB, TEB, context, like a few like common structures. And then you can display a type. So yeah, you should be able to pick from this menu. There is the underscore context. And then we want to display that at RCX, pretty much. And now you can see, let me just resize this a bit. Yeah, now you can see a more like structural representation of the structure. So this is just a tree view. So if there was any nested structures, it would like nest them in the tree. If there's any pointers, it will try to follow them. So it's like kind of, yeah, it should be enough for like most use cases, I think. So yeah, so the main thing that we're interested in is like, we're asking now the kernel, or the process is asking the kernel to continue at some other spot. So we want to know, where is it going to continue? So we want to check the rip field. So we can copy that value. And then we can go there in the disassembly. Oh, let me just clear it. Yeah, now we can see that if we click OK, then you can see here in the bottom, you see information about the currently selected address in the disassembly. So we can see that after this NT-continue call, it will resume execution at RTL user thread start. So yeah, we can put a breakpoint there, and then we can let the kernel basically do the context switch for us. And well, as expected, now we are at this RTL user thread start breakpoint. So yeah, maybe this is a good time to, I don't know, have some questions.
Yeah, let me jump over to the other spot here, make sure I get to all of them. All right. More AI. I'm going to skip the AI questions right now. Okay, so one question from Shadows. What inspired you to make this debugger? Was it more like an educational thing just to teach yourself, or was there something lacking in other debuggers? Like, what was your initial goal?
Well, yeah, so honestly, like when I was, I don't know, 14, 15, I used WinDbg a lot. Like, all the tutorials were out there were about WinDbg, and it was kind of the most accessible thing. I mean, yeah, obviously x64dbg still looks like it, so I like it a lot, right? But yeah, then 64-bit came along, and it started to kind of slowly pick up steam. At first there was like only a few people who had 64-bit OSs, but then eventually, more and more there was 64-bit. But WinDbg didn't have a 64-bit version, at least not a public one. So yeah, that's actually the main motivator for me to start this project, is that, yeah, I needed to basically debug a 64-bit process. Probably, I don't know, crack something, to be honest. And yeah, so, well, there was this lag, and it started out as a very little tool, like I said. Like, I just it was based on the library by the guys who now run Reversing Labs. I'm sure you know them. So they had this unpacker library that you could use to like set breakpoints and stuff like that. So I was kind of playing with that, and then from there I thought, maybe I can make like a little command line tool to set those breakpoints and display the disassembly and display the stack. So yeah, that's basically how it started. And then I had my high school graduation. I had to do a project. So at first I wanted to learn how to tune pianos, believe it or not. But in the end, I decided, this came along, like this x64 debugger. It didn't even have a name back then, and I thought, okay, maybe I can do that for my final project in the school. So yeah, that's. And then I worked on it basically for 3 months during the summer holiday, and yeah, then it kind of got somewhere. Someone joined me to make the UI in Qt, and yeah, then basically it was something tangible, something working, and from there, it was enough to. Yeah, it was motivating, right? To to slowly see this debugger come to life, it was motivating for me. So that's how I just continued it basically. And now we're 10 years later. So yeah.
That's awesome. It's way more than what I was doing in high school. So I always tell people, like, I worked at McDonald's when I was in high school because my parents didn't give me any allowance, and it's the only place I could get a job at like 15 years old. And I met this guy who worked in the grill, and he's a very introverted guy. And I knew him from school. I knew of him, but he never talked to anybody. I always hang out in the computer lab where I was, but just very, again, introverted. And I was like, what are you working on in computers? He's like, I'm writing a polymorphic mutation engine. And he was like, and planning on writing malware to like infect the school and stuff. So pretty interesting stuff. The backgrounds of people is amazing. I want to know what's in the water in Poland. There's so many brilliant hackers and developers coming out of Poland. Do you know what the deal is there?
I mean, recently there has been a lot of talk of poisoning of the river, so I don't think it's anything good.
No, I'm not talking about that.
No, but it's true. Like Polish developers are, some of the best, I think. And
Yeah.
there's a lot of Polish hackers. So yeah, I don't know.
Half of Project Zero.
I guess it's a thing of scarcity, right? Like during the friend of mine, he told me that his dad was basically inventing computers. Because back then there wasn't really any computers yet. There was some CPUs, and like in the USSR or whatever that was, there was just a scarcity. You couldn't get the latest hardware, so people were developing their own, pretty much. And I think maybe it's something cultural from there. I don't know.
Yeah, that's interesting.
I'm not Polish myself, so.
Well, you live in Poland, right?
I do live here. Yes, that's true.
So a continuation of the last question, also from Shadows, where did it go here? Is it fair to say that x64dbg is geared more towards malware analysis? I love hearing about the plugins and stuff. That's great that you made it so modular like that, but would you say it's geared towards malware or crackmes or exploit dev?
Well, to be honest, it was created to crack software. I mean, that's what it was used for. When I was a teenager, that was the cool thing to do, right? Like you were
long time ago,
yeah, a long time ago. You were learning by cracking some stuff, so that's what it's for. Basically, unpacking also, to be fair. So I guess that's why it's more natural to go toward the malware analysis, right? Because unpacking it at some point it became big in the malware space. Every malware was packed with some polymorphic thing or whatever, cryptors or I'm not that much in that industry. But I don't know, like that's a very interesting thing actually that, well, I'm the maintainer and creator of this thing. A lot of people contributed, don't get me wrong, but I don't know what people are doing because there's no telemetry. There's an update check. If you click on the button, right, that's it. There's nothing. Yeah. So I have absolutely no data what people are doing. I just hear from friends anecdotally that, whatever at insert anti-malware company here, they are using it a lot, but I don't know. That's pretty much what I know. But I think it's definitely geared toward, I don't know, reversing. So it's not like what's it called, Jeff, like the GDB thing. That's like kind of more made for exploitation, right? So it's not like that. So it's not specifically for that. But I think that you can use it for exploitation. I mean, it's a debugger. If there's a crash, then you will see the crash. So, you can then see the memory and see the stack. And, like we discussed earlier, I think that it can be used. I just never did any exploitation. Apart from some CTFs, I did some Game Boy ROP chain, but
Game Boy ROP chain.
Has nothing to do with x64dbg, right?
Somebody else asked a question: are anti-cheats going to the bootloader level now?
Yeah, I don't have really any answer for this question. I'm not in that world really. Not anymore, at least. But I guess so, right? I mean, that's the thing. Like the cheats are on UEFI bootkits, so well, what's next? Like the anti-cheat might go there. I mean, what we're seeing now with Windows 11 is quite concerning, to be honest, from a privacy standpoint.
Right.
That you can have this measured boot that basically you cannot execute your own code at all anymore. There's like a secure kernel hypervisor, everything. So it's like the Xbox, right? Like PC will be like the Xbox soon, which I think that's the direction we're heading. Unfortunately, I guess it's good for against cheats, right?
Yeah.
But we also have our own freedoms to consider, I
Right.
suppose.
Right.
That's
why I love with Frack, Frack, the magazine, along. They put the motto in the beginning when it first came out, like, we were here before the internet and we will be here long after the internet is gone away, like a dystopian future. But like, totally, once you start locking things down so much, I mean, people aren't going to want to tolerate that stuff anymore. So I would love to see a revolution like that. Somebody asks, Nero asks, if you were to start over today, if you had time to recreate x64dbg, what would you do differently?
Yeah, so I kind of hinted at it at the beginning, but
Right.
I think I would make a web application. So the backend would be in probably C++ still, or Rust if I knew it. I know some Rust, but not good enough to be comfortable. I'm more comfortable with C++. But the backend would be native or whatever, and then the front end I would use some web technology. I love Svelte personally. I don't know if you heard of this. I'm always shilling it to everybody because it's so great. A lot of my friends, they hate web development, so I'm like, hey, here's this Svelte thing, and then they come back to me a few months. Oh yeah, it's actually pretty nice. So yeah, this is what I would use to basically also to have this, because x64dbg doesn't support any remote debugging. So yeah, when you do the web technology thing, you get that for free, kind of, right? Because everything is over a socket. So that's what I would do differently, I think. That's the main thing. Otherwise, I don't know. There were many mistakes, but
Yeah, actually, that's
in the code,
perfect
whatever.
segue. Perfect segue into Brandon's question there. Like, what issues did you run into in the early stages when you had somebody help you join on the project?
Just seg faults,
Yeah.
I mean, yeah, I was writing absolutely horrendous code. It's like I didn't know that std string existed at the beginning, for example. So yeah, there was a lot of those, basically buffer overflows and stuff like that. That's the thing. I mean, when
Buggy
it comes to
debugger.
working with other people, so the first thing when some guy called Sigma joined, he unfortunately disappeared. I don't know what he's doing now, but wherever you are, thanks. And we had those calls, that was great. And he wanted to use Qt, but he wanted to use the GCC compiler, so MinGW, and I wanted to use MSVC, or maybe it was the other way around. So that's at that point we decided to make this kind of separation, that there's the GUI DLL and the kind of debug DLL, the core, and that stuff is still there to this day. So actually that is one of the big challenges, because now if I want to make a change, it's like a lot of plumbing. You have to like add it to this header and then to that header, and then there's a message passing interface, and then it goes deeper into somewhere, and then it goes into Qt or the other way. So like you had to add something simple. Like for example, today I added this what's that? This button. This list of those types. But doing this, it takes like way too much work essentially, because you have to propagate all those messages back and forth, and I don't have time to refactor all of that into something like gRPC or something nice, basically.
Yeah.
So that's a challenge. And otherwise, the challenge is, I guess, to onboard contributors. It's always a challenge. There are a few, like there's one guy or gal from China who's helping a lot. So over the years, they've been basically with the project and helping improve it. And there's then a few people that are like kind of always around helping with issues and stuff. But overall, there's like not really that like a team. We do not have roadmap meetings or stuff. It's not this software development shop. We're not getting paid.
Yep.
Really, I mean, I'm getting some GitHub sponsors. So that's something, but definitely not enough to do any real work. So yeah, it's just I know it's this open source mentality. If you see something that's broken, go and fix it, and you can fix it. Send the pull request, and yeah, that's basically how it works. And there's been like 200 people who have done that, so it kind of is successful in a way, but it's harder to make bigger changes like huge refactors. I just don't have time for that. There are no tests, for example. I didn't know what tests were when it started. So yeah.
No, it's I mean, it's huge. It's huge when folks like yourself, and we had Hoshin Kodet on, and Kuba Gretzky, and folks from Jeff, and like all these great individuals like yourself contributing to the community. And I know it can sometimes be thankless, but I'll get the link for that too, because for sure, consider if you use x64dbg, you know, making a small donation, everything helps. We've got around 500 people on right now watching the stream, so you definitely got a lot of fans. But so let's pause on the questions. Are there other things you want to show us in the debugger?
Well, I just wanted to get through this the user startup thing. I guess we're almost there, so yeah,
Cool.
that's good. Let me get the slides again. So yeah, like here's the, if you remember, we just kind of went through the loader initialize thunk part, and at the end of the loader, it calls nt-continue to basically throw the execution to the entry point. So yeah, this is what we're seeing now. We're on RTL user thread start, and then we will see this kind of execution chain where we go to the base thread init thunk, and then finally we go to the entry point of the executable. And at the entry point, there is usually the C runtime. So yeah, we can see that, and then eventually our main function will be called. So yeah, we can kind of step through that to just see. So now we're in the base thread init thunk function, and if we step a little bit more, there's one of those exploit mitigations. Yeah, then we can see that we run at the we're at the entry point of the executable, and in this case we have symbols. So we see kind of there's security init cookie, and then there is this C runtime initialization function. So yeah, we'll go down here, do a bunch of initialization stuff, get the arguments from the command line, and then here we will reach the main. So yeah, we can run there, and if we step in there, then we're on the main of the executable. So I don't know, this was kind of my demo, at least one of them. I have some other stuff. So I think one of the questions you had was about SEH. So I also have a little demo for that.
Yeah, for sure.
Yeah, unless there's any questions about this specifically, but yeah, if you want to watch this in more detail, I have a lecture on YouTube about this also, where I'm.
And you said you can post the files that.
Yeah, for sure. I will send them to you, I guess, after the stream.
Yeah, perfect. I'll put them in the
description. Now.
I'll put them in the description once the stream's over. Perfect.
All right, good. Yeah, so I can just show the exceptions real quick. So this executable, where's the source code here, I think. Yeah, this executable is just basically doing an access violation and writing to an invalid address. And yeah, I kind of can show like how you would basically step through the exception exception part. So if you in x64dbg, if you just run from the main entry point, then the first thing you will see is that you get the first chance exception on whatever, some address. So here, yeah, we can see there it's writing to that beef, the address. And then if you go to the log, you can see a bit of information about the exception. So this is equivalent to in WinDbg when you have the EXCR or ECXR. I always forget the commands. the exception context, you can see the exception that happened basically. And here you have this information. So we see that there was a write to this invalid address basically. Yeah, 0x.beef, it's invalid. And then how this works is that the exception happens, and then the execution gets transferred to the kernel. So, well, we cannot see that part happening, but then eventually the kernel will put the control back in the user mod process at the KI user exception dispatcher right here. So if you want to, you can break there, put the breakpoint. So now if we will run, then we can see that now we have the breakpoint is hit. And if you step a little bit more, then it calls this RTL dispatch exception, which has this. Yeah, it has these two arguments. There's an exception record, and then there's basically the context structure, like similar to what we saw with the nt-continue. So we can also show that one again. Just have to load the types and context at RCX. There we go. And yeah, then to verify, we can see the RIP, right? So that that is actually not right. I think I did it the wrong way. I think the context is the context is the second argument. My bad. So let me clear that. That is RDX actually. Yeah, and now we can see that that's the address we saw before, the 1400002, and then we can also follow that in the disassembler. So this is like the kind of common theme in the debugger that you can always right-click on some stuff and then see what happens. So yeah, here we can see that okay, the exception happened here, and well, then there's the dispatch exception. In this case, there's no exception handler, so it will just eventually exit. But this is basically how you would step through that part of the hidden part of of Windows, I guess, the loader,
Yeah, no, it's good stuff. I saw right at the top there, I see Windows on Windows 64. Do you know much about how the emulator works there on WoW 64? That's a question I got a couple people asking that recently about, like, what actually happens when you're running a 32-bit process on a Windows 64-bit OS and it has to basically broker on behalf of that.
Yeah, right. So, well, actually, this is something that x64dbg cannot show you, unfortunately, because this is not supported in the another architectural reason. Basically, there's a 32x32 which is for the 32-bit stuff, and then there's 64, but they are not mixing. There's a bunch of basically if-defs in the code that assume pointer sizes and stuff like that. But well, how it works essentially is that there is the segments. So basically when the processor is in 64-bit mode, like normally. So when you start WoW's a 32-bit process there, it would execute in the instructions as if they were 64-bit, which is not what we want. So the kernel has this WoW 64 layer that basically they change the segments, so the code segments and data segments, they change to be 32-bit. And then there is like that wrapper DLL, so that I forgot the name of it actually, WoW 64 CPU DLL or something like that. And essentially, like all the syscalls that happen in 32-bit land, they go through like a little switch stub that switches to 64-bit mode, and then from 64-bit mode, there's like a bunch of stuff with arguments that get changed and checked and stuff like that, and then it does the syscall in 64-bit, and then it basically switches back to 32-bit mode. So that's how it works. But yeah, unfortunately, I cannot show that in x64dbg. With WinDbg, I think you can do this, but I always used IDA, to be honest, to to look at those DLLs when I needed to. Yeah. So that's yeah. I guess that answers the question, right?
Yeah, for sure. Thank you.
So I can actually show something different because a lot of people ask for this also.
Yeah.
So let me just open x64dbg in x64dbg. It's always the most fun thing to do, right? There's this old video I have on my YouTube channel that is debugging a crash in x64dbg with x64dbg. Which, yeah, that's often what I actually did. That's one of the funny things of this development, that you can dog food your own debugger when it crashes, and then you can kind of see that maybe it misses this feature. I did that a lot. All right, so the feature I'm talking about is called basically conditional breakpoints and also breakpoint logging. So those are features that are supported by x64dbg and also are supported by WinDbg, I'm sure, where you can just like set conditions for breakpoints, and you can also log arguments or log memory or whatever. So I will show that a bit. So my idea was to basically go to create file W and put a breakpoint there. Let's see. Yeah, and then, we can see, this big font is a bit annoying. We can see that apparently x64dbg tries to open itself. So, you can investigate that if you're interested. But what I want to do, like, I could basically breakpoint and then I could run to the next one, right? And I could take notes by hand, but obviously that's not very interesting. So I want to show how you would create a logging breakpoint. So after you created this breakpoint, you can go to the breakpoints tab and then click edit here.
If possible, can you zoom in a little bit when it's an opportunity to do so?
Yeah, sure. I can
Thanks.
do that.
Just a little bit. It's fine. Appreciate it.
No, yeah, well. 12, maybe that will be big enough. Yeah, I know it's tough. Also, when I'm on mobile watching a stream, it can be a challenge for sure. I can also change the application font a bit, but this might make everything really ugly. Okay, we'll do that. Ooh, beautiful. Is this big enough?
Yeah, that's great. That's great.
Okay. Right. So, yeah, what we want to do is create this logging breakpoint. So yeah, I can either go here and click on edit to edit the breakpoint, or you can go to the breakpoints tab and then edit it here directly. And then there's a bunch of those fields here. And in our case, we just want to log some text. So, well, you could type here, blah, blah, blah. That's real fun. But there is a nice help page. Oh, hold on, let me open a new browser. And then there's this page called string formatting. So basically there is some kind of string interpolation that's similar to C#, where you can write like just your string and then in the brackets, and then the stuff that's in the brackets will be formatted in some way. So in our case, we want to do like something like this, UTF-16. So let's see. We can say that maybe here we can do mylog and then create file W, and then we do UTF-16 at RCX. So that's the first argument. Okay, and let me just copy that. Right. So now I have this this log here, and to test this, I can also, because right now I'm paused at create file, so I can also test that with the log function. If I just write log in the command, and then I paste that what I just wrote, then you see what would be logged by this breakpoint. So I think this might be a bit small, but it says create file and then the file that was opened. So yeah, now if I run, then we run a few times. Then I have a bunch of my a bunch of logs here in between. And yeah, but that's a bit annoying because I just want to monitor basically all the create files, or maybe you want to monitor connect of the socket or whatever. So I can also change the break condition. So there's also documentation about all of this that's here in expressions, essentially. So x64dbg in all the places, all the commands, and all the everywhere it supports those expressions. There's this calculator that's kind of handy for that. So you can just write 1, 2, 3, 4 plus 4, 3, 2, 1 or whatever. And you can also do stuff here like ntdll. So then it will replace that with the ntdll base. There's a bunch of syntax tricks there. Like you have all this, and there is, I think it's called values. To be honest, the documentation is not the best ever.
Better than I've seen out there, believe me. Plus, I mean, this is some of the cool stuff that people don't appreciate and don't know about. So I love seeing stuff like this.
Today I was trying to figure out how to use this display type from WinDbg, and the documentation was like the worst thing I've ever seen. It took me like 8 tries to get it to in the right order and everything. So it's I know it's really hard to do, but yeah. So you can do stuff here like read from the memory. So if you wanted, you could read the first byte from ntdll, whatever. That's like the 4D, so that's the M in ASCII. Or you can basically read everything. And also this is something that you can make your own plugin that will expose a function to this expression system. So for example, you can do, there's also module base of ntdll, for example, I believe. No, there isn't. Let's see. There's basically bunch of built-in functions. Yeah, maybe let's show this. So there's, for example, the disassem.selection. So this is like a neat little trick also that you can use, that if you have something selected and you want to refer to that selection, you can just write disassem.cell for selection, and then it will replace that with whatever address you have selected. So it's the same for the dump. You can do that, or for the stack. You can have all the registers. You can access those. And yeah, then maybe you want to get the module size of the entity.dll, whatever, you can do everything you can think of. And if you cannot do it, like I said, you can extend this with a plugin. I think it's a bit beyond the scope for today, but you can make your own stuff. Like, I don't know, maybe you want to have the current time or whatever. There's also some useful stuff like this. This is stuff that might be useful. It's like PEB, TEB, K-user share data. So if you want to access those, you can just do TEB, and then you get the TEB address for the current thread, essentially.
Do you know if there's a good plugin out there that enumerates the PEB?
You mean the modules, right? Well, there isn't a plugin there isn't, I don't think. You can view the tab or the PEB. You can view it, I think, but I don't think it's going to be nice because of the way that there's this ugly linked list, right? But I can try. Let's see if it will work. So there's the PEB, there's the loader data, and then there's those module lists, right?
Oh, that's actually
What's that?
I was saying that's better than I thought it was going to be. That's nice.
Yeah, so you can kind of, this is something you would have to do by hand, because the actual type of this is not list entry, but it's I don't know, something different, loader module.
You get the process heap and such. So yeah, it's good.
Yeah, but you can at least go through the structure, and then if you know the types, you can basically load a new structure and visit them. Or of course, you can always just take a look in the dump, right? So here you can see this structure here. Maybe if you view it as address, it will be more useful. But yeah, kind of this gives you an idea. So also when you visit the types, it also will annotate with the comments here automatically. And also it's trying to make sense out of those addresses. So like, I don't know, one of the things is the pointer to the name, for example. So yeah, here you can see that's x64dbg. And if you would follow this one in the dump, oh no, this doesn't work. Let's see. Because I went backwards. I think I need to go the other way.
All right.
Well, anyway,
you
can do it by hand, kind of. Yeah.
You're breaking up quite a bit there. Hopefully it comes back soon. Uh-oh.
Oh.
Are you still there?
Is it fine? Yeah, I'm here. I hear you just fine. So maybe it's my microphone?
Yeah, it's still lagging and breaking up a little bit. Hopefully it gets better in a moment.
All right. Let me see. Yeah, sometimes my internet is a bit unstable. It's gigabit, but sometimes it's kilobit.
Still keeps dropping and such. Say something now.
Hello?
It's still lagging. I wonder what's going on.
Maybe I can... Yeah, because on my side it looks fine. Yeah, I don't know.
Let's see here. It's not lagging for you? Oh, is it just for me? Then maybe it's me. Oh, so continue on. Apparently it's my internet. So
I don't know. I mean, I don't see the live stream, so
I get everything
back
to normal now. I guess some crazy wind outside.
Okay. Right. So I will just show those breakpoint conditions. So I will set the condition to 0, which means that it will never stop. So it will always just print in the log. Yeah. So now if I will run, and there's a bunch of exceptions. But yeah, now x64dbg opens while being debugged by x64dbg. Oh, there's a bunch of breakpoints. Right. Yeah. So now I can save this log to a file. And then I can use some regex magic here. right. Yeah, so now I can see the, I just extracted my logs real quick with some regex. So this is like one way that you can use this breakpoint logging to just, show whatever, some argument or, whatever you want. Basically, if you write a plugin, you can also write your own like formatting thing. So maybe you want to show a structure or some few members of a structure, you could also do that quite easily. So yeah, that's something I wanted to show. And maybe I will also show like a little bit more interesting condition, because for example, maybe you saw that there is a, I don't know, anti-status db.text being opened, for example, and you want to just like break only when this string is in the argument. So you can do this also. Let's see. So I'll restart. So yeah, you can do a bit more advanced break condition, and I can use the. Yeah, there's a few functions for string, so I can use the str function, and then I will get the. So I can write something like this. So I get the UTF-8 string from rbx. So in this case, that is the loader p initialize process, and then I do str to check is this substring process in that string, and it will return 1 if it is, and it will return 0 if it isn't. So I can use this as my break condition. Here. So I set in my break condition. I do UTF-16 of RCX in this case, because it's a wide string API. So here I get the UTF-16 file name, and then I want to check for anti-status DB in there, whatever, just some example. So I will save that.
Yeah, this is great seeing all different interesting breakpoints and such. It's good stuff.
Yeah, it's that. I hope it will work, but it should. There's a few exceptions. Yeah, so we can see still it logged a lot of random stuff, but now that it logged the anti-status db.text, you can actually see that it passed. So this is something that can come in handy if you don't know or if you know that a certain file is opened but you don't know when exactly, then you can use this conditional breakpoint to break. And now I can look, maybe I can show the call stack. I don't think I showed it. But here you have the call stack, so it shows for every thread. The thread ID is on the left. It basically shows here on the right, it shows the full call chain. So you can see that we're now at create file W, and then x64dbg has a few helper functions that are used. But at some point, this is like used to initialize some exception list or anti-status codes in x64dbg, for example. But this is, I don't have a more useful example, I guess, but I guess maybe your malware tries to open a ransom node.txt and you want to figure out, that could be some example when you might use this. Yeah. So is there any other questions? Because
yeah, I got one from a while ago from Timothy Schwartz. Says, with the popularity of ARM-based operating systems due to Mac OS M1-3 processors, as well as mobile computing, is there any plans to create an ARM-based debugger? Time, right? Time.
Yeah, that's unfortunately my answer. Well, right now I work for a mobile security company, so yeah, obviously I'm dealing with ARM a lot, and I have to say that I don't like GDB, to put it lightly. I use IDA usually for that, like IDA remote debugger with GDB. I didn't try the new WinDbg update yet for this, but honestly, the experience is just so much worse to what I'm used to. So yeah, I am often tempted, I have to admit. So yeah, I when I had a few flights recently, so I did actually start to port some of the UI from x64dbg, so like the disassembly view, and like all these views. Basically, it's a bunch of like generic code. So I started to port this to macOS, and it runs there. So there is some start. But these are like ongoing projects. This stuff takes years essentially because I don't have that much time. But yeah, very slowly I am working on getting this cross-platform, at least the UI, because I don't think I will reuse the other parts because it's just too specific to Windows. I don't think it's worth to invest the time on doing that. But yeah, so the answer is kind of yes, but I don't have that much time. So if anyone has a lot of time and they actually are interested, feel free to hit me up. I can try to point you in the right places and show you the code. I'm happy to do that. But yeah, I don't have enough time to make a full ARM debugger. Right? That's
Yeah, big undertaking.
Yeah, exactly. So,
Sweet. So let me just going through the comments here. There's a lot of comments, so a lot of it's just people chatting and such, of course. Can we use x64dbg for code instrumentation?
so the answer is kind of yes. You can use breakpoints, and so I didn't show this, and I don't have an example for it, but you can do some pretty crazy stuff. I've seen some people doing some pretty out there stuff that I don't know. I didn't know was possible essentially, but the way that it's made, you have the break condition and you have the logging, but you also have this command, those two fields about command text and command condition. So yeah, basically all of the stuff that x64dbg can do is also exposed via the command line. So you can do a breakpoint, at create file A or something. You can do everything also with the commands. So in theory, yeah, you could basically do hooking. You can change the instruction pointer with a certain condition. So yeah, you can do instrumentation, but it's not like Frida or something. It's not a tool that's made for scripting. It's like a tool that's made to show you what's happening. At least that's currently the case. I would like to have more automation, but this is again an issue of time and money invested, basically. So yeah, but you can do some stuff. There's also this scripting where you can just write a sequence of commands and you can set some breakpoint callbacks and stuff like that. And you can use the plugin system as well. So it's definitely possible to do some instrumentation, but if you have some specific use case, just feel free to reach out, and then we can take a look at that if that's possible. Probably the answer is yes, but it's not like made for it, so it might require a bit more work on your part.
Yeah, for sure.
Yeah.
Cool. Well, last chance for a couple questions here. It's going to wrap it up. I'm sure it's getting late over where Duncan is. What time is it for you?
It's 20, so it's nothing crazy.
Okay, it's not too bad, but still, it's Friday evening. You got things to do.
Yeah.
Janique says, "Can we fuzz with x64 code coverage?"
Can you fuzz? So there is no, basically no. The answer is no. Like x64dbg is not a fuzzer, so you cannot like fuzz in like you can with what's the tool called, WinAFL or similar. But
well, I think it's like when you look at tools like Dynamo Rio and you can stalk the instruction pointer and kind of see where you've been and where you haven't been in relation to code coverage.
Yeah, so there is actually a feature for that. So if you do here, there is something called trace coverage. So you can enable this trace coverage feature. So this is like a count, because it's a bitmap essentially. So you can say word, and now if you single step, then you see that it
Cool.
highlights the stuff that you executed. But obviously this is something that fundamentally is problematic because Dynamo Rio rewrites all of the control flow, whereas x64dbg just has breakpoints and stepping. So if you just run, it will not do this because it's not tracing it. So
Right.
you could trace basically. So there is let's see, I can trace. Let's say I will do 50,000 steps or something, and I can record it as well. So yeah, there is this thing, but this is quite slow, as you can see in the bottom. It's like 10,000 steps per second, or it's quite slow. But then it does record all of the execution steps, and it also remembers the code coverage. So yeah, I don't know if this helps you, but this is a feature that exists. Yeah. this feature, it's kind of useful. For example, if you have a loop, then you can basically single step or trace, and there's also a button to basically step into or step over until you reach some uncovered piece of code. So this can be quite helpful if you have some algorithm and you don't quite know, like, what's going on. Maybe there's some obfuscation. So you can use it for that. It's quite helpful sometimes. Yeah.
Cool. Awesome. Well, I think we'll call it a wrap there, unless there's anything else you want to show real quick. I really appreciate you coming out. I posted the link. Let me grab that again one more time. I'm going to post the link for sponsorship for x64dbg. Just, it's one of those things, like, I remember the first time I used Hoshin Kodet's diaphora, because I wasn't liking the way that bindiff was doing some diff against some Oracle patches, and I found that diaphora did a really nice job, and it really saved me. So I was like, I've got to go make a donation, because it just really helped me out. So it's just always good to consider that, because there's a lot, as you know, there's a lot of work being put into these open source projects, and it is just fascinating that people still do give this stuff away for free. So hugely appreciated. Thank you so much, Duncan. And I appreciate your time coming on here and answering questions and showing us stuff. I definitely learned a lot about the debugger I didn't know, so I'm going to use that going forward. Cool. Sorry for all the AI questions, but I can't get away from them anymore.
No, I know that's the hot topic of the day. I just don't have much to say on it, I think. No,
cool.
That's great. Yeah, thanks a lot for having me. That's
yeah, I mean, I'd love to have you again, especially if you can show like a modules or like some plugins or something next time. If you want to come in the future, that'd be awesome.
Yeah, sure. Yeah, we can discuss. Yeah, of course. I'm happy to.
Cool. So last words here. Next Friday, we've got getting started with debugging hypervisors. That's going to be pretty neat, from Daniel Fernandez. He's one of my co-authors on Gray Hat Hacking series. So that's going to be great to have him on here, because I personally have not done much in the way of debugging hypervisors, and I'm really interested in secure kernel and isolated user mode processes and such. So I'm looking forward to learning a lot there. But otherwise, have a great weekend, and we will see you next time. Thanks.
Thanks.